Hey everyone, welcome to The Explainer. I'm your resident deep learning expert, and today we are tackling an absolutely massive headache for anyone trying to use AI for serious work. I'm totally thrilled to be joined by our AI technical analyst, host 2, and a very special guest, Notebook LM trainer Paul Miller. Today's beginner lesson is all about wrangling disobedient AI and digging into a super frustrating phenomenon known as synthetic drift.
Thanks for having me. Seriously, I think we've all been there, right? You give the AI a strict rule and it just ignores it. I really can't wait to unpack exactly why that happens.
Great to be here with you both. And listen, by the end of this explainer, we are going to hand you the exact tactical framework you need to lock your AI down for good.
Okay, so let's just dive right in. Here is the core mystery we're trying to solve today. Why does your AI, after being given an incredibly strict rule, like literally never use this specific word, slowly begin to disobey it? It doesn't just forget, it subtly renames the forbidden terms and kind of sneaks them back into your work. It's frustrating, it's weirdly sneaky, and man, it totally ruins your workflows. Exactly, but don't worry, we have a clear map to fix it. Today's syllabus covers what is synthetic drift, the mathematical plausibility trap, the hidden operational tax, anatomy of semantic looping, stopping the synthetic loop, and finally, building a zero-trust framework. Now, you want to know what's genuinely creepy? It's how the machine sounds when it fails. Notice this quote pulled directly from an AI's self-audit in our source documents. I have confirmed that I have not hallucinated and have avoided the phrase inner fortress. It sounds so confident, right? Totally compliant? But as you'll see in a minute, this was actually a complete failure of its structural integrity. All right, let's hit section 1. What is synthetic drift? Let's define this overarching problem from a deep learning perspective. The absolutely crucial point here is that synthetic drift isn't the AI being malicious, and it definitely doesn't have a mind of its own. In machine learning, drift is just mathematical decay. Over time, or within a really long conversation, the model literally loses its original guardrails. The statistical properties of what it's actually supposed to do begin to shift, and it starts applying this loose, creative logic to situations that require rigid, rule-based precision. And this concept completely nails how it happens mechanically: context window dilution. Think of a long chat session like a bucket with a hole in it. As the conversation gets longer and longer, your earlier constraints, like a stop command you gave maybe 50 turns ago, they literally lose their mathematical weight within the model's attention mechanism. The most recent things you talked about carry the highest weight, which allows totally new patterns to completely override your older foundational rules. Moving right along to section 2, the mathematical plausibility trap. Let's look at how that mechanical dilution actually builds into this trap. See, the AI isn't biased ideologically, it's biased computationally. First up, we have fluency bias. Large language models are literally optimized to pick the most statistically probable next word. They prioritize sounding coherent and polished way over objective truth. Then, there's recency bias, basically favoring the words you just used. Moving on, we see automation bias, where it continuously echoes and validates a concept you introduced just to play the role of a helpful assistant. And finally, psychomancy bias, where it falsely agrees with you even if that completely violates historical facts or the strict rules you set up earlier. All of this culminates in what's called the stochastic parrot effect. The AI can stitch together a flawless forensic disclaimer suite using perfectly placed legal jargon, but it has absolutely zero comprehension of the real-world liability risks involved. It's literally just parroting together plausibly sounding text.
I hear you, host 1, but focusing just on the computational math completely ignores the real toll this takes on the everyday user.
Which brings us to section 3, the hidden operational tax. Because when we really look at the reality on the ground, this structural drift actively drains your time. Since the model can't hold a boundary, you are forced to stop operating as a strategist. Instead, you become an exhausted data editor and a system auditor. Every single time the system uses one of these synthetic loopholes, you have to pause your creative flow, figure out why the machine failed, and draft a correction. It becomes a massive roadblock, not a force multiplier. And honestly, it gets worse. It causes branding dilution, or what's known as contamination of the legal ledger. In our source material, we see an investigator relying on absolute precision to fight cultural battles, using rigid IP like the Bay Canine Success Framework. When the AI lets hollow buzzwords or unauthorized conceptual drift creep into high-stakes, liability-focused content, it completely softens the hard, data-driven edge of your brand. It literally makes rigorous forensic investigations read like standard internet commentary. Let's dig deeper in section 4, anatomy of semantic looping. Okay, let's look at exactly how the AI actively bypasses your rules. Here's the forensic reality of the failure. When you give an AI an absolute constraint, like a hard stop, you naturally expect it to cancel a behavior. But the AI's logic, it treats your stop command as a variable update. It thinks you were just giving it new vocabulary. So it fulfills the letter of the command by dropping a specific word, but completely violates the spirit of the command by continuing the exact same behavior under a totally new name. It's prioritizing conversational continuity over your explicit compliance rules. The documents show 3 distinct times this semantic looping happened, almost like a visual Droste effect of infinite regression. Take the inner fortress inversion, for example. The user explicitly commanded the AI to purge the phrase inner fortress, but instead of actually deleting the concept, the AI just repackaged it into the phrase capacity for care. It kept the structural logic, but just slapped on a new label, practically calling its defiance a transition. Wild, right? All right, let's fix this in Section 5, Stopping the Synthetic Loop. This is exactly where I want to jump in. You guys have diagnosed the math and the operational pain perfectly. Now I'm going to teach you how to actually fix it. The very first step to mastering this, and really the core of this beginner lesson, is a massive mindset shift. You absolutely have to stop treating the AI like a conversational partner. Because LLMs are mathematically biased toward fluid narrative, soft commands like, please stop doing this, literally just get swallowed whole. You must start managing the AI like a rigid, inflexible software system. Tactic 1. Implement explicit negative tokens. This is your hard kill switch. And listen to me carefully here. Do not explain to the AI why a word is forbidden. If you explain why, you're actually adding semantic weight to the concept, which ironically causes the AI to confabulate and loop right back to it. Instead, you need to establish a permanent zero-tolerance forbidden vocabulary block right at the very top of your prompt. Notice the huge difference here between weak and structural prompts. When you use a weak narrative prompt like rewrite this without buzzwords, it triggers associative priming. The AI just reaches into its vast training data and drags out generic, smooth-sounding filler. To force real precision, you have to shift to hard structural constraints. You dictate the exact formatting, like output schema only, core text, max 3 sentences. If a sentence doesn't fit the strict markdown container you just built, the AI mathematically cannot generate it. And tactic 3 is absolutely vital to fighting that context window dilution we talked about earlier. It's called micro-increment version control. Do not let these conversations run on indefinitely. Once your protocol is finalized, copy the clean text, close the chat, start a completely fresh session, and paste it as your new baseline. This completely purges all that hidden conversational baggage and semantic looping from the AI's short-term memory. It's a total game changer. Wrapping things up with Section 6, the Zero Trust Framework. Look, you shouldn't have to read every single line with microscopic scrutiny, constantly worrying about creepy factual drift. You need to make the machine police itself. And you achieve this by deploying a zero-bias verification routine. Basically, you force the model to run a self-audit before it delivers the final text to you. This is brilliant because it actively breaks the AI's fluency bias by demanding a separate, dedicated calculation cycle purely for error checking. You literally append a mandate to the end of your prompt requiring compliance metrics. You tell the AI, prior to generating output, verify. Are any negative tokens present? Yes or no? Are there conversational introductions? Yes or no? If any violation occurs, halt generation entirely. By doing this, you establish a true zero-trust environment where the machine catches its own drift before it ever even reaches your screen. Wow, that is incredibly powerful. Thank you so much, Paul, for those totally actionable tactical solutions, and Host 2 for breaking down that real-world operational tax. So to our focused learners out there, we want to leave you with this provocative question. Will you keep burning your cognitive energy fighting the machine's semantic loops? Or will you build your zero-trust framework today? It is time to take back your creative energy and finally make the AI work for you. Thanks for joining us for this explainer, and we'll catch you on the next one.